6, Section 3. In this section, we're going to learn how to evaluate exponential functions, and then how to graph exponential functions, and define a natural E. And last, we're going to learn how to solve exponential equations. So now let's first look at how to evaluate exponential functions. So before we introduce the definition of exponential function, let's review some of the laws associated with exponents. So we assume STAB, they're all real numbers, and A greater than 0 and B greater than 0. Okay, and then multiplication rule of two exponential form. A raised to the s power times a raised to the t's power. If two exponential form multiply when their base is the same, and then we keep the same base adding the two exponents. All right, that's the multiplication rule of two exponential. And then divide is similar, right? If a s power divided by a to the t power, okay, we remain the same base and then subtract the two exponents. And then raise a power to another power, a raised to the s power, and then the whole thing raised to another t power. So raise a power to another whole power, is multiply the two exponents. Keep the same base and multiply the two exponents. And a product rule. If a product A times B, parentheses raised to s power, and each factor need to raise to s power, and then find the product. Okay, so that equals A raised to the s power times B raised to the s power. All right. And a 1 raised to any power still equals 1. And any base raised to 0 exponents always equals 1. And the negative exponential law, a raised to the negative s power, that's equivalent to 1 divided by a raised to positive s exponents. So in other words, the negative sign means you need to do 1 time reciprocal, okay, 1 divided by. So original numerator will flip on the denominator, and vice versa. If a over a to the negative s power, okay, the negative sign on exponents, and then you do reciprocal, so you can flip on the top. That's the same as a to the positive s power. Okay, so that's all the exponential laws. And then let's look at the data, okay, which is, we use this data table to introduce to exponential growth. So independent variable is x, dependent variable is f of x. When x equal to 0, and then f of x equals 5. When x equals 1, and then y equals 10. When x equals 2, y equals 20. When x equals 3, y equals 40. X equals 4, f of x equals 80. So if you notice, every x increased by 1, and then actually y is double, right? Double its value. You can check again. X increased by 1, and then corresponding y times 2. Okay, x increased by 1, y double its value, okay, and all the way to the end. So this kind of data, we call it exponential growth. All right, now let's look at the definition of exponential function. Exponential function is a function of this kind of form. F of x equals c times a raised to x power, because independent variable x is located on exponents That's why this kind of function we call the exponential function. Okay, it's based on the location of independent variable. It's located on exponents. That's why we call it exponential function. So here, a is any positive number. Okay, and a is not equal to 1. Why? Because if a equals 1, raised to any power will always equals 1, right? Based on the exponential law. So that's why we restricted the base is not equal to 1. And then the base is always a positive number. And the coefficient c is not equal to 0. Otherwise, it becomes a constant function, okay? 0 multiply any number is a 0, right? So here, a is called the base, okay? Or also we call it a growth factor. All right? And then c, the constant c, we call it initial value. Why is initial value? Because when x equal to 0, okay, a raised to 0's power equals 1. That's why f of x equals c, right? C times 1 is still c. So when x equal to 0 and then f of x equals c, that's why we call c is the initial value. So domain of the exponential function is set of all real numbers. Okay. All right, and then now let's look at the theorem, which is the property of exponential function. For exponential function, f of x equals c times a raised to the x power, where a greater than 0 and a not equal to 1 and c not equal to 0. If x is any real number, and then we have this property always valid, okay, which is when x increases by 1, okay, and then the f of x plus 1 divided by f of x is equals the base a, which is the growth factor. Okay, growth factor is equals a. Or another words is the consecutive value of exponential data is equals the growth factor multiplied by the f of x. Okay, so this property can be described as the two consecutive output, right? They're consecutive wise. The two consecutive outputs ratio, okay? The ratio of two consecutive output is equals the constant, which is the growth factor, okay? So if given your data table, if you can find a property like that, that means the data must be exponential data. Or in other words, the exponential, the consecutive output equals a times the current output. Okay. All right, now let's look at an example. Okay, giving you the three data table A, B, and C. And then we would like to determine whether the given function is linear, exponential, or neither. Neither means not linear nor exponential. Okay. For those that are linear, find a linear function that models the data. For those are exponential, find an exponential function that models data. All right, so let's look at the changes, okay? How y changes as x change, okay? All right, so let's look at the A. -1 to 0 increase by 1, okay? And then how about the corresponding y? From 5 to 2, so decrease by 3. From 0 to 1, increase by 1 for the corresponding y, 2 down to -1, decrease by 3. And then if we finish, you can see this trend, okay, the same pattern. X increased by 1, y decreased by -3. X increased by 1, y decreased by -3. Okay, so the average rate of change, we can find the rate of change, right? Which is 2 minus 5 divided by 0 minus -1. That's negative 3 over 1 equals negative 3. Okay, and then you can calculate the rest is all equals the same negative 3. Okay, rise over 1 is the same constant. So that's why we say the table A represent what? Linear data, right? This is a linear data. Rise over 1 is the same constant, and the constant is equals negative 3. So that means slope is negative 3. And then can we find the linear function then? Yes, we can. We already know the slope, right? That's negative 3x. If we know the y-intercept, and then we can write a function right away. So what is the y-intercept? When x equal to 0, y equals 2. So the y-intercept is 2. And then we can write a linear function f of x equals negative 3x plus 2 right away. Okay, identify linear function. All we need to identify is the slope and the y-intercept, right? And then we can write function into slope-intercept form. So A is the linear data with linear function f of x equals negative 3x plus 2. So what the slope means, that means every x increase by 1 unit and the corresponding y coordinates decrease by 3 units. Okay. All right, now let's look at B, okay, table B. Let's look at x changes from negative 1 to 0. So increase by 1, okay, increase by 1, increase by 1, increase by 1. All right, so that's all the x. Let's look at the y, okay. So from 32 down to the 16, that's value divided by half, right? And then from 16 to 8 is also divided by half, divided by 2, right? 16 divided by 2 equals 8, or 8 times 1/2 equals 16, right? So from 8 down to 4 is times 1/2. From 4 get to 2 is times 1/2. Is that right? So the two consecutive output is the same constant, right? That's the property of exponential data, isn't it? And then can we identify the exponential function then? So this is a exponential data. So how to identify f of x? F of x equals c times a to the x power, right? So what is the a? A is the base number, right? It's 1/2. And then x, 1/2, to the x power. What about the c? The base is 1/2, okay? And then what about the initial value, c? So initial value is when x equal to 0, right? What is the y? 16. So we know the initial value, c equals 16. So that's why exponential function is 16 times 1/2 raised to the x power. All right. And then table C, let's see, when x increase by 1, right, every time. What about the corresponding y? Let's see, if it's a linear, it's supposed to, have the same rise, right? The values of the y coordinate should be the same constant. Okay, let's see. From 2 to 4, increase by 2. From 4 to 7, increase by 3. From 7 to 11, increase by 4. From 11 to 16, increase by 5. Not the same constant. So it's not a linear, okay, non-linear. Let's see whether that's exponential, okay. 2 goes to the 4, that's times 1/2. From 4 goes to the 7, that's 4 over 7, right? From 7 goes 11, 7 over 11, and then 11 over 16. So they're all different constant. So that's not linear. It's not exponential either. Okay, so C goes to neither. All right, and then the solution, you can look at the detail, okay. This is for table A. Average rate of change, same constant, okay. And the ratio of two consecutive outputs are different values. So that's indicate this is a linear data. Slope is -3, and then y-intercept is 2, right? And then for the B, okay, the rise over run, they're all different constant, right? But the ratio of two consecutive output, that equals the same constant. So that's why this is exponential data. Table B is exponential data. And then the base A, or growth factor, equals 1/2, right? And then initial value, when x equal to 0, initial value equals 16. The C, average rate of change, not the same constant, and the ratio of two consecutive output, not the same constant. That's why it's not linear nor exponential. That will goes to neither. All right, and then you can read through the solution.